All right, nerds. We are going to start a new unit. This unit is obviously all extra credit because that's how coronavirus works. Because it's extra credit, I'm going to tell you all the stuff that you don't need to know because it's extra. So I'm going to tell you the extra stuff. Okay, so we're going to start a unit called Conic Sections. Conic, root word here is cone. That's because it's made of cones. So we are going to look at, this is like a 3D thing. This is an ice cream cone with another ice cream cone connected at the tips. And the tips right here, that spot's the origin. Yeah, so like X and Y, X goes this direction. That's X. We'll say Y goes that direction. And then Z is this direction. Z goes up. That's Z right there. Okay. So X is kind of like out of the page. It's like at you. Okay. Y is sideways, and then Z is up and down. Okay. So we've got two cones. The equation to make these cones is pretty easy, actually. It's x squared plus y squared equals z squared. So that's the equation of this 3D cone. If you can graph that in a 3D thing, you get these. So the way we get conic sections, the reason they're called conic sections, is because we take cross sections of a cone to get different shapes. And depending on which way we slice our cones, that determines what shape we get. So today what we're going to look at is the easiest way we can slice things, and we get circles out of it. So what we're going to do is this thing here, this is a plane, like a XY axis, but it's flat. It's like a piece of paper, right? So we take it and we slice the cone with it. Then we look at what shape is the end of the cone where we sliced it. It'll make a circle, right? So if I cut it with that thing, like this is a razor blade or something, real sharp, slice it, pick up this piece of the cone, look at the bottom, it'll make a circle, right? You can see this is kind of not the 3D version. This is slice it sideways, look at the bottom of this thing, and you're gonna get that shape. So the equation for this shape is x squared plus y squared equals r squared. Super, super similar to the shape of our cones, or the equation of our cones. You're just replacing z with r. So you'll notice the farther up you go along the z-axis, the bigger your circle gets. It's almost like z is the radius of your circle. It's so crazy the way math works, huh? So anyway, that's what we're going to look at today. We're going to look at the section of this cone that we get when we slice it just straight horizontally. And they're going to make circles. Okay. So now that you kind of have an idea of like where this comes from, this is all the extra stuff. If you don't know any of this, that's fine. If you don't ever remember this, or maybe even that, sorry, wrong finger, the name of that, don't worry about it. Like, if you're not going to calculus, it's probably not a big deal. If you are going to calculus, it's a huge deal. Okay. Have fun. I got ink on myself. Oh, you made me ink my pants. All right, so let's talk about circles specifically. Oh no, I got ink on my table. My wife is gonna kill me. Nobody tell her. The general equation of a circle is x minus h, that whole thing squared, plus this plus sign here is super duper muy importante. Super important. Make sure it's a plus. Okay. Y minus k squared, that's a k. You can tell. I spent so much time on this k. Look how beautiful this k is. That's the best k I've ever written. Okay, equals r squared. H is going to be the horizontal shift of our circle. So we're going to take our circle and slide it left and right. And then not gay, excuse me, I misspoke. K, wouldn't that be funny if we had a gay circle? I don't have a rainbow pen. Vertical shift, that's going to take our circle and move it up and down. And then r, notice this is r squared, just r is the radius. So if our radius were like 3, because this is r squared, the number you would see here would be 9. So just keep in squared. R is the radius. The equation uses r squared though, so be careful there. Okay, the other thing we need to talk about is this is minus h and minus k. So if you saw x minus 3, h is positive 3. Because the minus is part of the equation, it's not part of the value of the number. So whatever number you see in here, switch the sign and that's actually h. So for example, if we had something like, let's say x minus 3 squared plus y plus 2 squared equals, let's see, Gabby, what's your favorite number? 7. Oh, okay, Gabby, you gotta listen to what I mean though. R has to be squared. Give me a perfect square, dingus. Don't give me a non-perfect square. Oh, Bart, you didn't say that. Yeah, I know. Okay, now give me a perfect square, kid. 25. All right, great job. 25. I miss you guys. Really, I do. Okay, so if we look at this example, you're gonna say, oh, look, h is negative 3, k is 2, and r is 25. No, you're wrong. Look, h is the opposite of this thing. So h is positive 3. Remember, the negative is part of our equation that you can't see. The negative 3 here is the negative from the equation. So h is just 3, so h is positive 3. All right, k is, this is minus a number. What number has to go in here to make this plus 2? Well, minus a negative. So the k is actually negative 2, so you just switch the sign that you see in the problem. So k here will be negative 2, and then r, remember this is r squared, so you have to take the square root of this number. So r would be 5, and our circle from the center to the edge would be 5. Okay, cool. So there's your general equation. Here are your what all those variables go with. Now we're going to look at 3 examples that kind of cover the gist of what you're going to be asked to do with circles. Circles aren't super crazy complex. But we're going to look at 3 examples, and I think there's a little bit at the end I want to add just to like review stuff you should definitely already know about circles, but in case you don't. Okay. All right, so our first example, they're asking us to graph x minus 2 squared plus y plus 3 squared equals 16. All right, so typically your circle is going to be centered here at the origin, but because we have the minus 2 and the plus 3, it's going to shift. So the first thing we want to do is find the center of our circle. So the center of your circle is going to be at the ordered pair HK. So we need to figure out what are h and k, and then we should probably figure out what's r as well, just to have it, because we're going to need it. So let's figure out h and k, just like we did on the first page. H equals something. I'm sure k equals something as well. And then r exists. Okay. So h is always with the x because x is the horizontal axis, so it controls the horizontal shift. So it says minus 2. Remember, the minus is part of the equation, so we just take the 2. H is 2. And then k is, remember, flip the sign, so this is going to be negative 3. Okay, so h is 2, k is 3. Remember, this is r squared, so we have to take the square root of it to find our actual r. So square root of 16 is 4. So our radius is going to be 4. With these 3 numbers, you have all the information you need to graph your circle. Because this is honors, I know some kids can be like, but Barton, what about negative 4? Okay, tell me, you draw me a circle that has a radius of negative 4. Like, what does being negative 4 feet tall mean? Like, you're negative 4, you're less than 0 feet? No, shut up, that's not a real thing. So we throw away the negative. Technically, yes, we took a square root, but we just want the positive number because, you know, lengths can only be positive. Okay, so first thing we're going to do is write down our center. Our center is at HK, so the center for this circle is at 2, negative 3. Okay, so let's go to 2, negative 3. 1, 2, 1, 2, 3. And then put your center on there. you should graph the center. I understand, and you're like, but that's not on the circle. But everyone graphs it so that you can see, because knowing where the center is really useful for most circles. So it's good information you should have. So you can go ahead and put a point there even though it's not like on the circle. Okay, so radius of 4. Once you know your center, we're just gonna go 4 in the 4 different like cardinal directions and kind of mark off our boundaries and then draw a circle. So 1, 2, 3, 4. That's the right edge of my circle. Then I go back to the center. 1, 2, 3, 4. That's the left edge of my circle. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then now if you're like really good at visualizing stuff in your brain, you can kind of like see the circle here, right? If you're like good at art or something. The rest of us are just going to do our best and draw a circle. I'm bad at it, so you know, just whatever. As long as I can kind of see you meant a circle and I can see that you don't go outside the boundaries, that's really the important bits, right? Like, if I wanted a real circle, I'd have to use a compass. I have one. You could go get one. That might be fun. Like, what else do you have going on? You can't go outside. Okay, so there you go. There's a circle. Yeah, and you could like smooth it out. I don't really care. You probably won't even have to graph it because it's online. But that's how you graph a circle. Cool. So find your H, K, and R. H and K tell you where your center is. Put that in the middle. Find R by taking the square root of this number. And then you go that far in each direction from the center. And then circle. Cool. So that's graphing a circle. Now we're going to kind of just do the reverse of that for completeness sake. We're going to look at finding the equation from a graph. So I have a graph here that I already made. First, we want to figure out our H, K, and R, because those are the 3 numbers I used. Those are the 3 numbers I picked out of the equation to make the graph. So if I can get those 3 numbers from the graph, I can just plug them into the equation, right? So here we go. Our center is right here, so we're going to figure out where that's at. You just count. -1, 2, so left 2. So our center is at -2, and then we went up 1, so 1. Okay. Remember, this is going to tell us H and K, and then here we can just count our radius. They probably won't ask you to find the equation without a nice radius. Like, they won't make it hit some weird thing. You know what I mean? Like, it'll be nice. They won't. Or they'll give you an exact point and you can calculate it. So there's our radius. It's 2. So R equals 2. Okay. All right. Now we're going to plug these 3 numbers into our equation. So this number right here for our center, this is the H, that's our horizontal shift. And then this number is our vertical shift of the center, so that's our K. And then there's our radius. So we'll just plug these 3 numbers into our equation. So we're gonna have X minus H, so minus -2 would be +2. Make sure you square your parentheses. Plus Y minus K, so K is 1, so it's going to be -1, equals R squared. So R is 2, we square that, it's 4. Okay, and then that is the equation for your circle. That's all you gotta do. I'll probably ask you for like specific things. I'll be like, what number should go at the end of this? Like, I'll give you x squared plus 2 squared, or x plus 2 squared plus y minus 1. Oops, almost forgot my squared. Good catch, Mr. Barton, you're a genius. Equals, and then like a blank. I'll be like, what number goes there, right? And then you'll have to look, oh, the radius is 2, and then I'll catch most of you. Be like, you messed up, caught you. But then the other smart kids will square and go for it, you know. So okay, so there's the other example. We've got one more, and then I'll just like review some other important circle stuff, I guess. Yeah, okay, here we go. Last example. Okay. Find the equation of a circle whose center is at 1, -2 and passes through the point 6, 2. I tried to make this a really nice problem, and then I realized that I'm a dummy and I don't remember Pythagorean triple triangles, right? So we're going to get a really nasty number for our radius, but this is honors, so, you know, put on your big boy underwear and you'll be fine. All right, so we want to find the equation of a circle whose center, look at that. They just gave me most of the answer. What dummies. This is H and this is K, right? So we already know most of the equation of our circle, but they didn't tell us the radius, so that's going to be the tricky part. So let's fill in what we know, right? We have x minus h, so minus 1, squared, don't forget the squared, plus y minus negative 2 will be plus 2. Don't forget the squared, equals, and I'm going to leave some room for my r squared there. We'll come back and fill it in later. So in example 2, they were really, really nice. Look, they just showed me the radius. It was 2. It was nice, right? This one, they're jerks, and they give me this other random point, and it just seems random, right? It passes through this point. So I drew the center, and I drew the edge. You could kind of try and draw the circle if you want. It kind of goes like that, I guess. So we want to know, what is that thing right there? How far is that? Because the center to any point on the circle, the definition of a circle is everything's the same distance from the middle. So if you know any point on the edge, the distance from that point to the middle, that's your radius. So to figure out this radius here, we just need to do the distance formula to figure out that line segment. So we need to know how far over does it go and how far up does it go. So change in x, change in y, and then we do the Pythagorean theorem on that. So this we can just count is 1, 2, 3, 4, 5 over. Up is 1, 2, 3, 4. So if I want to know r, 5 squared plus 4 squared equals r squared. So this will be 25 plus 16 equals r squared. So that, what's math? 41? Something like that? Okay. So you're going to say, oh, I want to know r. Take the square root. So r is radical 41. And that doesn't simplify. 41 is a prime number. But here, remember, this is x minus h squared plus y minus k squared equals r squared. I don't want to put square root 41 here. I want to put 41. I want to put what is r squared in there. So make sure you put the correct answer for what goes on the other side of the equal sign. So use distance formula to find your radius. Make sure you plug in your radius squared into the equation. Okay, cool. So there you go. There's the important stuff about circles. Other stuff you might want to know. Just this is just okay. Lessons done. Over. Pre-cal done. You've learned all your pre-calculus. Congratulations, you're a freaking genius. Here's the important stuff about circles you should remember from like 3rd grade in case you forgot it. I don't know if it's on your homework. I haven't written it yet. So here it is. Area, A, equals pi r squared. That's important. You should just know that. You should have a tattoo of that. That's like how much stuff goes in the circle, right? Circumference, 2 pi r. That's the distance around the edge. What else do you know? Diameter equals 2 times the radius. Oh, do you guys know arc length? That would be important. Nah, just kidding. Yeah, we'll put it in there just because I said it. I don't want to tantalize you and not tell you, right? Arc length, usually S, is your radius times the angle you go through. So it's like, if you have a circle, you want to know how long is just this little piece here. It's the radius of your circle times theta, which is the angle. Okay. I probably shouldn't put that there. That's a math symbol, but anyway. Footnote. Theta is in radians. Okay. Anyway, there's that. So you guys enjoy your homework this week. It'll be circles. It'll be easy for you. If you didn't get any of my beautiful notes, you can go ahead and rewind the video and just watch it again. Or you can Venmo me $50 and I will personally explain it to you for an hour, because that's my tutoring rate. It's $50 an hour. But you're my student, so I'll give you guys a discount, $49.99 an hour. Email me if you need anything. Stay safe. See you guys.